Before I start, I need to apologize to some of you who were on a workshop yesterday because you already heard all of that. You can just go to the party straight away, right? For the rest of you, there's been quite a lot of talk today about microservices, containers, clustering, scaling, stuff like that. So I feel that what you're going to hear now is mostly, it's in a way almost a summary of what you heard throughout the whole day, right? We won't go very technical. I'm just going to try to give you some pointers and some ideas how to deal with your systems in the future, right? Or right now, whenever you're kind of ready. Right, so first a bit of introduction. My name is Viktor. I live in Barcelona. Travel a lot. I work for a company called CloudBees. We're a company behind the enterprise version of Jenkins and probably the biggest contributor to open source Jenkins, of course. I'm also a member of a group called Docker Captains. We're kind of a group of enthusiasts and people working with Docker for a long time, in a way promoting it. I'm not employed by them, though. Published some books. We can go to that later. So let's move a bit in the past. It all started in a way quite some time ago with continuous integration and continuous delivery, continuous deployment, right? We all try to automate things as much as possible, right? And try to get the whole flow from commit to your code repository all the way to the production as much automated as possible, right? So with time we started having certain steps. We started provisioning our environments, testing the provisioning, building environments, again test, deploying, testing, enabling, testing, right? The flow is all about doing something, testing that something, doing something, testing that something, all until it gets to production, right? And it's safely running there. Now, what I observed is that very often people think that that's very tense, right? This is our flow, and once it's in production, it ends. At least it ends in a sense of automation. We automated everything. It's in production. We can go home, right? Actually, the truth is quite different than that. At least the truth in the world we are living today and what we are trying to accomplish today. There is quite a lot missing after continuous deployment. We need to monitor our deployment. We need to monitor our servers, our services. Everything that is running in production needs to be monitored one way or another, right? We need to react to problems that are occurring. That's obvious. Server is down, we need to do something about it. Service is down, we need to do something about. There is too much load on our servers, we need to do something about. We need to react to problems as they're happening, right? And equally important, actually more importantly, we are slowly trying to move towards ideas of how to prevent problems from happening in the first place, right? Now, the monitoring and reacting to problems, that's not anything new, right? Any of you who was ever operating production servers already did that, right? You monitor your servers, you sit in front of huge screens that show you some graphs, some numbers, you look at them, and it turns red, then you react to those problems, right? But that's quite ineffective because the speed with which we are moving right now, or we are trying to move right now, does not allow us any manual action. At least not any substantial manual action anymore, right? Because manual actions take too much time, simply. There is no time for somebody to call you in the middle of the night and say, this is wrong, get up from your bed, fix it, and 2 hours later, thing is working again, because our users are gonna get unhappy, and unhappy users mean a very bad thing for our business. So, those are the things that, at least I'm concentrating right now, how to automate all this second part of what comes after you deploy things in production. But before I get into, let's say, tips, what should be done, right? But really the major problem that I observe with customers and that I've worked with is that they have in a way, wrong wrong assumption of how their software should be architected, right? And that's the idea from a long time before that, okay, we should design our software, spend quite a lot of time designing and developing and all that in order to make it perfect, right? They're trying to accomplish some kind of perfection. Take whatever time you need, but make me my monolithic application. It is always going to work, right? It's never going to fail. And then if you have a bit more money, then you say, okay, let's put just 2 servers, so if one server fails, we don't know what we're going to do if it fails, but if it fails, there is another one, right? But it's a misconception that actually anything can be made to run perfectly, which is completely wrong, because you're going to have bugs, your applications are going to fail. It's ridiculous to even think that application can handle any load, because whatever your current hardware is, it is limited, and assuming that your business is growing, the amount of traffic that you're going to be getting is going to increase, and so you cannot do that. You are going to make bugs, you are going to do stupid things and commit it to the production, and if you embark on a train of doing continuous deployment, whatever mistake you make, if that mistake is not caught by the process, is going to enter the production immediately, right? And finally, you're hoping that was from before, quite some years ago, right? We were buying those huge, expensive servers, spending tens of thousands of euros or dollars into a single server because that server is supposed to be great, right? It never fails, it has such a good hard disk memory and whatever, it simply always works. Right? And we were spending, at least in case of organizations I was working for, we were, for example, spending quite huge sums of money on servers just because they have certain guarantees, right? But the summary of all that is that we were trying to accomplish some kind of perfection, right? And there's nothing wrong, actually, in trying to accomplish perfection. That should be a vertical all of us should try to do. But the problem with that is that usually it makes us blind on the other aspect of what we do, and that is being prepared for wrong things happening at the wrong time, right? Kind of, it sidetracks us from designing our applications to react to failures by trying to make them never fail. There is no set. I mean, it's proven over and over. There is no company who managed to make anything perfect. It never works as it's supposed to, especially not in the long run, right? Applications fail quite often, more often than we would like to. Services or applications that we are developing and deploying cannot handle whatever we want them to handle. Commits, hardware breaks, things simply happen. So, when I was, my closest analogy of what we are trying to accomplish now, I think, or actually for quite some time, is we are trying to make something that is very similar actually to life, right? How life, be it human, animals, whatever, works, right? And life is a very good example of something, of a system that is extremely resilient, right? It survives everything. Whatever happened, and quite a lot of things happened throughout eons, but life is always there, kind of. It's indestructible. And it's indestructible because it has certain properties that we are lately starting to put into software, right? To apply those properties and features into the way how we design things. One of those properties is that what really matters is system, never individuals. That's one of the first wrong things that I think that we are doing today. We are trying to make this individual, turning back to software, this application really matters. This instance of this application matters. It does not, right? Same like with life, the system matters. Whether one individual or one individual goes down, it dies. Really, it's completely almost irrelevant for the system itself. As long as the system is alive, we are fine. Individuals do not really matter. We all like to think that actually we matter something, but for a system as a whole, we don't. Second thing, and the second aspect is something that we actually passed a long time ago, in a way we are thinking, and that you can relate to Agile against waterfall movement, right? Very small, extremely small, as small steps possible making towards a certain goal in a very rapid incremental iterations, right? And that's exactly the same thing as with how evolution works, like very small, rapid evolutionary changes, right? And there were quite a talks today and then questions kind of, we're gonna Dockerize everything. Don't Dockerize everything. Dockerize one application, move forward. Never try to make your whole system today be Dockerized because it's just fancy. Docker is great, but never try to do a big bang. Please, that's the lesson that most of us learned quite some time ago, right? Another aspect is reproduction, right? That's probably one of the most important features of life that made it succeed during all this time, right? It's capable of reproduction on all possible levels, right? And finally, we're getting now more closer to the subject of my talk, self-healing, right? Your body is capable, in most cases, not all, to self-heal, right? You get some virus, your body reacts to that, and just automatically gets you rid of the virus, right? Doesn't work always, it works most of the time, right? So, and that's, now we're getting to the point why I think that microservices are such an important movement in our industry, is it actually reflects the analogy of having, again, of our bodies, for example, cells. And cells are very important, and it's very important why we are compromised of huge amount of cells, right? For simple features that they provide. That's that each cell is capable of restoring itself into state of equilibrium, right? Our cells reproduce themselves, they never recuperate themselves individually, but the total number, looking in the system, is more or less balanced, or according to the current needs that you have, right? Our bodies are monitoring themselves, adjusting proper processes, reproducing, healing, etc., etc. Now, if you would try to apply that same logic to the system, to things that we are constructing, right? These are the things that we definitely need in a modern system, right? Anything that a very small hobby site, in a way. We need a data center, right? That's equivalent even somehow to our brain, right? Brains. We need a data center that's going to manage everything and do things by itself without our intervention, right? Now we need that data center is something ephemeral. It's a certain number of servers. We don't even care how much, except when the bill comes. And then we need some kind of orchestration that is going to make sure that everything is deployed to those servers, to the data center properly, right? Next, we are, again, going towards microservices, which, again, same thing like Docker is not answer to everything, but it's becoming a very almost provenly well thing to do in many cases, right? Containers, again, not always, but very useful new feature addition that we got into our toolbelt lately. And we need to be capable to scale, right? And scaling, I'm going to get to that subject soon, but scaling is usually misunderstood by many, at least many that I spoke with, right? And finally, self-healing. So, any type of system that tries to be automated all the way around, that means not only your continuous deployment flow, but what is happening in your system from there on needs to be capable of doing certain things. And one of them is to discover a problem, right? We cannot have automation that fixes the problem before it discovers, kind of follows certain logic, you know? That is restoring itself to desired state, and that's again one of the things that people confuse that desired state with designed state, right? Design state is something that you decide when you design your system. This is my design state. But from that moment on, from the first deployment onward, desired state and then design state start to differ because whatever you design at the beginning changes almost from the moment you deploy it to production because different conditions are applied to your system all the time, right? So desired state is something very dynamic, something that changes very often. Again, it needs to make decisions, and it needs to adapt to the change conditions, whatever the conditions are. Increased traffic, for example, is the simplest possible example of those conditions that are changing all the time. Now, in order to make your system capable of doing self-healing, there are different levels, again, from which we should observe things. And one is the application level. I'm not going to go much into it, but that's simply how do you code your application to be prepared to handle problems of any form or way, right? From the simplest try-catch statements, which usually are not enough, to more complex things like, in my case lately I've been involved in ACM, for example, which is a very handy way to handle how you're, but whatever you do, make sure that your applications are the first barrier against any potential problem, that inside themselves they're capable of recuperation from things. Now, next one is system level, that in my case gets a bit more interesting, and we're going to speak about it mostly now for the rest of this speech, right? And hardware, which is quite different depending on whether you have on-premise servers and cloud, right? And one of the big reasons why cloud is becoming so popular. So again, apart from different levels, we have different types. Reactive approach, we react to problems and fix them, which is usually not, almost always not enough, because between problems occurring and us reacting, there is a downtime, there is a problem, there is a performance issue, for example, right? And then preventive. Now, there are 5 prerequisites that I think that everybody should be able to fulfill before even considering anything more complicated, any more complicated implementation of their search system, right? And usually they go, usually people approach them in the same order as I'm going to explain them here, because they start from easier to more complicated techniques, let's say. First one is ability to deploy to any server inside a cluster that meets hardware requirements, right? And until recently, that was almost unimaginable with many, because first issue that we had, any of you have a name for their servers, like in my case, at least before, I had a server called Garfield, server called Snoopy, and stuff like that, because I knew that server is where this application will go, right? But now where we're moving is that servers do not exist as a concept that we care about. It's a cluster, right? My application can be deployed anywhere inside of the cluster, and it will work fine to any single server that meets certain requirements, right? That's the first step. So simply, and that opens certain problems, right? That opens the problems of if your application can be deployed somewhere and you don't know where, somewhere within a cluster, you don't know what the IP of your application, you don't know what's the service, you don't know what's the port of your service, right? You don't know where it's running before you run it. And that means that your configuration files need to disappear, right? Whatever you had in that .properties file that says, my database is on this IP and this port, stops being useful, starts being very dangerous, because as long as you have that configuration file, you're not capable of doing things that we're going to do, I'm going to speak about later, simply because that database is fixed and it cannot be moved. If that node fails, the database that was configured, hard-coded in some configuration file needs to be there, or somebody needs to go and do some changes manual that will finally introduce certain type of downtime of undesirable effect that cannot be fixed very fast. And I think that, who was it? Carlos, I think, mentioned Kelsen Tower was saying about how would you design your system if you're never able to log in, right? And that's one of the first steps. Can you make your system work without ever entering with SSH there, right? If you can accomplish that, that means that actually you're starting to think in terms of a cluster, not in terms of individual servers. And the second one is ability to deploy without downtime and scale and descale instances, right? Now, everybody's getting crazy, me including, about Docker, right? You check out the code, you build the container, you deploy the container, happy, right? Next commit comes, you check out the code, you build a container, you deploy the container on top of the previous container, right? That's what some of you must have been doing that right now. Now the problem with that is that you have downtime. You cannot simply deploy things on top of other things because there is a millisecond, second, minute, whatever is the time that your application is to initialize is the time of a downtime. Or in best case scenario is a decrease in performance of your system if you have multiple instances and do some kind of rolling update, right? So, at least the best way that I found to mitigate that problem is blue-green. Anybody familiar with blue-green deployment? Apart from those yesterday's workshop? Those you don't come? Okay. Basically, the idea is very simple. It's just that without containers, it was very hard to do before. And that means you have your release, it's running in production, everybody happy, proxy going there, and then you deploy new release in parallel. Never replace the old one, test it in production. People get scared when I say that, and then just change the proxy, right? Always run at least, at any given moment, at least one release is running. There is never downtime, at least never downtime made by deployment. And second thing that is missing in most of scheduling, cluster schedulers that I've seen by now, that includes, I'm not going to even name them, is relative scaling, right? We all use, like you use Swarm, for example, to scale to 10 instances, but what you want to do in most cases is scale using relative numbers. I don't want to know how many instances are currently running, I want to increase the capacity by 3, right? So never absolute numbers, because your systems, the scripts that you will be creating in order to make your system really resilient is to be able to calculate what is the current status, this, increase by 5, decrease by 3, to whatever you need to do some kind of calculation. Number 3, ability to monitor hardware and dynamically adjust cluster capacity, or be elastic, right? That's something that most of on-premise installations are incapable of doing, simply because there is a limit, right? If you have your servers with in your own on-premise, inside of your company, you cannot grow whenever there is a need to grow, right? Because simply assuming that you will not gonna buy 1 billion servers just in case, and today I need 5, but I'm gonna have 15 in reserve. You're not gonna do that because it's too expensive, right? You don't wanna grow before you need to grow, but when you do need to grow, you wanna grow instantly, right? And when you do need to grow is, oh, for some reason there was an announcement on television for my website, suddenly I have increase in traffic, I wanna expand immediately, right? And that's one of the things that where people compare that and say the cloud providers are expensive, which in a way they are. But when you compare with, if you have that ability to grow when you need and go down when you don't need things, scale, and equally importantly, descale, then actually price is not that much different than, and often can be actually quite cheaper than costing your own servers. So. React and prevent, again, reaction is, there is increase in traffic, oh my god, what should I do? Call somebody to increase the capacity. And finally, prevent means that I know that something bad is going to happen with the cluster, with servers, I'm going to prevent it from happening. Meaning, I have a data from last week and I see that my CPU is steadily increasing the usage. I know that when this moment comes, I will need more of it. And we are now entering into story about how important it is not only to monitor stuff, but keep the records of everything going in your servers, everything going inside of your cluster from the dawn of time. Because that information is extremely valuable if you want to predict what's going to happen. Like, I've seen cases of people saying, oh, my hard disk reached 80%. I should do something about it. Not necessarily, because maybe it will continue being on 80%. Maybe it was already on 80% for a month. and it's going to stay there. But if you have that historical information, you can see what is my tendency, how, with which speed something is changing, so that I can predict what's going to happen tomorrow, what's going to happen in the future. It's kind of like having a crystal ball, right? Number 4, apart from hardware, which is easier, monitor services in near real time and execute reactive actions, right? Do you have a system that is constantly monitoring what is going on? Which again, is becoming a bit more complex than before, because before we had things static, right? This application is running here on this IP, this port. Put Nagios or whatever product you're using and just monitor that application. But now, application is somewhere, right? And next moment it will be scaled. The moment after that, this scale is going to move from one server to another. It's continuously changing. So the ability to monitor what truly means is that this ability to observe the changes in a cluster and then monitor what's going on. So it needs to be very dynamic, right? And execute, and then depending on when things happen, this service is down, do something about it by whichever scripting or whichever language or system you're using. So you need some kind of checking of your services, and you need you need to be able to redeploy anything, anytime, fully automatic, right? No human interaction, because at the end of the day, it's the same process from the beginning of this presentation, when you have continuous deployment. Just rerun it again whenever something goes wrong. And finally, predict the future. This is the crystal ball part. This is the funniest part, and the part that actually takes most time. And do some proactive actions, right? Some sort of this process we've been doing, most of us, for quite some time, because the first step is usually schedule scaling, meaning that we use our memory, right? Somebody from, I don't know which department, knows that every first day of the month our sales increase, and then somebody goes to Jenkins, let's say, and says, day before people receive their salaries and come in huge numbers to our site, scale up, and 2 days after scale down, right? That's the easy part. That's a part that one way or another, even manually, we've been doing for a long time, right? But what is more complicated is what I touched before, scaling based on historical information, right? Can you find out what was your traffic tendency yesterday at the same time and use that to predict what should be done right now, right? What was happening last week at the same day, but last week, last month, during certain period of time or short period of time. The number of calculation is extremely big, but the first step is, can you do a simple math and use that math together with your historical data to decide what should be done next. Now, just a quick from theory to something more concrete. Tools, at least those tools that I've used, which are in no way finalist, like, especially that is changing from one day to another, probably. Whichever tool did not exist yesterday in this area, maybe there is today. But we need certain types. So we need a cluster orchestrator. You heard many talks today about cluster orchestrations. At least I attended 3, I think. Real-time registry, historical registry, monitoring, and general orchestrator, right? So for cluster orchestrations, you heard, at least Mesos was here twice, I think, today. So you already heard about it. It's a tool that's been around longer than any other tool that I know of. At least any other tool capable of doing certain things that we expect it to do today. It's proven to work, very robust, works in production in many cases. So it's in that sense, it's a good choice. It's not a good choice in the sense that it's becoming old. It's not designed with the current tools that we're using today. It's a bit feels weird for Docker if you're into Docker, but if you're not into Docker, then definitely this is the choice, right? And Kubernetes, just for those of you saying containers are a new thing, they are not a new thing, and then Kubernetes is in a way proof that they are not a new thing, because Kubernetes is the result of Google's experience of using containers for at least 10 years. Just not Docker containers, because Docker did not exist until recently, but containers themselves did. And Kubernetes is not what they use internally, but it's a product based on the experience of using containers internally, and it's very kind of popular. And robust, and finally the newest kid on the block, Swarm. Again, same thing, orchestration done by Docker Inc. All three of them do. The major goal that they have is the same. Manage to deploy your stuff to the cluster without you knowing where it goes and should even caring about where it goes. And then they differ in certain approaches that now we don't have enough time to go through those differences, right? Now, real-time registry. There are three major players again, and this is what replaces your configuration files. Your configuration files should not exist anymore. This should exist, and those are all three are distributed key value stores that are replicating data among all instances they have, so that actually there is never a loss or almost never a loss of anything, right? Again, Apache being longest in a game, proven to work, used in many cases, it's a part of Mesos, so you know that it works in production, but it's JVM, so it's slow for what it's doing. Newer kits, Consul, etcd, Consul I think is going to become more and more popular and used by most, right? But this is when you store your configuration files, not in files anymore, configuration data. Now, historical registry, that's Elasticsearch, at least. Now, definitely there are others like Solr, right? But Elasticsearch is the one I had most experience with, so I couldn't, without feeling that I'm cheating with others, which does not mean in any form way that Elastic is the only one we should do, but it's pretty awesome because you can throw anything you want at it in any format and it will find it when you need it in no time, extremely fast. The only problem is filling your memory, so prepare to have gigabytes and gigabytes of memory wherever it's running. Monitoring, those two tools should go to history and we should applaud them because they served us well for many years. They are not capable of doing handling the dynamism that we are expecting today anymore. So what is coming is again Consul, which is capable of, apart from doing key value store, to actually do some monitoring in a really good way. And finally, I had to mention Jenkins simply because, at least in my case, there's the long before I joined Jenkins, actually, there's the general orchestration that they use for most of the things, simply because all those tools that I spoke about before, and together with all the processes that we spoke before, need to be run by somebody, and that can be Jenkins, or if you're into something else like CircuitCI, Bamboo, Travis, whatever you're doing, that's all fine, as long as you have a place where all the processes are defined and run completely automatic, right? I don't know, how are we with time? Yeah, good. Okay, questions. This is my blog if you want to read it, this is my book if you want to buy it, and now you can ask questions for 10 minutes before we go and get drunk at the after party. Anybody?
Does it happen that your human scripts will just shut down the system because it fails to see that it's still running?
Yeah, kind of. Who monitors the monitor, no?
Yeah, it's a risk that the monitor would shut down your whole system just by thinking that it's not running or something.
Yeah, that depends a lot on the type of tool you use. For example, if you use Consul, which is my current preference, and it changes from one day to another, Consul is distributed across all your cluster if you choose to, right? So, as long as one instance is running, as long as one node is running, something will be checking. It will be checking things, right? Now it also depends on the type of strategy you use for checking stuff, right? There is a push model in a way that you can have your monitoring tool that pings your services or does something like that. And then you have a TTL model of time to live, right? If I don't receive response message from my service, I assume it's dead. But the most important thing, this monitoring tool, and that's where Nagios, for example, fails and similar ones, is that your services need to be distributed, right? You need to have multiple instances of your services, so that if one or multiple instances die, there is always something running, right? Same thing applies for everything else, not only for services that you design and develop, right? Monitoring tools, they need to be scaled as well, precisely to avoid fault tolerance. Proxy needs to be scaled. Cluster orchestration, like Swarm, needs to be scaled. So now there is always this scenario that if your whole cluster dies, then who's going to monitor, who's going to tell me that it died? Then you need multiple clusters, right? Multiple zones in AWS or whatever you're using. But there is always the, what if whole planet loses electricity? Then we're really in a messy situation, nobody will tell us. But there is always that risk. It's just, it's impossible to reach the point where actually everything works always and it's auto-recuperating. That's more like a goal, and let's see how close we can get to that goal. Right? There are circumstances that your monitoring might fail on all cases. Nothing is perfect.
Very interesting. What is your future vision? Who will be writing software in 5-10 years?
Humans.
Still humans?
Yes. Because the difference is that, I don't know, you said 5-10 years? Or 55?
5 to 10 years.
Yeah, 5 to 10 years. 5 to 10 years for humans, definitely. Because I think that we are very far from I don't know, machines doing that. But the direction we are moving is that we, humans, are more and more involved into creative parts of our work, right? And creative means that something that is done once, right? No line of code or no function that I program within the same application system is the same as the other, because otherwise I'm doing crazy stuff. I'm just copying and pasting things. No, assuming that I'm not copying and pasting, when I call the application, I'm doing creative stuff that was never seen before, right? In a way. But anything else that is repetitive, the same, like operations, you do the same, most of the time the same thing, right? Automate. Automate everything that is repeatable and leave to humans fun stuff, creative, I think. But anyway, more and more automation, definitely.
Any more questions?
You described very well the system level self-healing tools. What about application level? I'm curious about application level self-healing tools.
That's not that much about tools, because that's what's happening inside of your application. That would be libraries, and even more importantly, how you, which coding practices you use and things like that. I usually don't put much detail into that, because it's very hard to say something that works for everybody, because I assume that in this room only there are probably 20 different languages people write in, right? And I'm definitely not an expert in all of that. But I often use Akka as an example. I don't know how many of you heard about Akka, right? Akka is a way of programming, and it's a tool in a way, if library is called a tool, that actually allows you to do stuff that is much less, in a way that is much less prone to failures, and recuperate is much easier, right? But there is no really tool that you plug in. It's more about how you program, which is the difficult part.
No questions.
Nobody.
No questions.
Nobody.
So,
Give him a present.